Welcome to Tuesday. Make sure you complete your attendance check-in today. I know I say that every day, but I have to count so many people absent every day because you're not doing the attendance check-in. So make sure you are doing it. I do not want to have to count you guys absent. If you can't find it or you can't figure it out, email me, do something. Don't get counted absent just for not attempting it, okay? Today we're going to keep talking about domain and range. We're going to talk about continuous domain and range today. Note, I have a little reminder on here that there is no school on Friday. So Friday is a teacher work day. So you guys would not have been coming to school anyway on Friday. So this Friday, woohoo, you don't have to worry about doing any attendance check-ins or doing any work. I won't be posting anything. It is a holiday for students. Okay, let's get started. Let's move on over to our Canvas here. So remember, click this daily attendance check-in button. And after you finish doing that, remember the attendance check-ins should be at the top of the page. I'll go ahead and show you. Actually, the attendance check-in button and the today's work button. Oh no, something's wrong. It kicked me out of my student view. Y'all cannot see all of this, I don't think. But they're the same exact. The daily attendance check-in and the today's work, they take you to the modules page, guys. You haven't figured that out. So do the attendance check-in. It'll be at the very, very top. And then you can just scroll to the bottom of the modules page and you will see your work for today. So we're going to do continuous domain and range. This is technically notes, but remember, we're going to do it in Cami so we can write on it and we're going to work it together. So you need to click load in a new window. And it should bring it up. Uh-oh, looks like I have messed something up. So hang on just a second. I'll be back in about, 2 seconds for you guys. Let me come over here and open this thing up. It's not wanting to open. Okay, I'm back. I think it's going to work now for us, hopefully. So let me come back over here. I remember yesterday I told you guys I was going to show you a way to remember domain and range, and then I never did it. So let me come over here real quick, and I want to show you. This is one of the ways that I remember domain and range. So I write it like this. I write range this way, and then I write domain. Let me see if I can leave enough room here. This way. So I can remember it this if I write it. Range going up and down. Range and domain going side to side. Range going up and down. Because what this reminds me of is our X and Y axis. Okay, so Y is up here. X is always on this side, going side to side. So that helps me remember domain and range. So domain is my x's. It goes the same way as my x-axis. Range is vertical, the same as my y-axis. So some of you can, it helps some students. They'll picture this in their brain and they'll always remember domain and range. So maybe if you're a visual person, that will help you. That's another way to remember. Domain is your x's, range is your y's. Okay, so let's come back over here. Now I can click load in a new tab. And it's going to bring up this page for us right here. So we want to talk about, I don't know if y'all noticed this little toggle arrow down here. It'll show you the descriptions if you want that, what each tool does. So we're going to talk about continuous domain and range. So I want you to think back to yesterday when we were doing domain and range, and we literally were listing out all the X values and we're listing out all the Y ones. They were given to us in tables. They were given to us mappings, list of ordered pairs, and then we had some graphs where we could actually count the points on the graphs. So when you do continuous domain and range, you're always going to be doing it from a graph or they'll give you an equation sometimes, but you're going to take that equation and you're going to graph it. So let's talk about continuous. Let's remind ourselves, let's write at the top again one more time, what is domain and what is range? So let me get my colors again for you. So domain is it's all possible, every single possible X value. Now our range, on the other hand, as we just said, is all our possible Y values. So that means we have to list out every single possible x value and every single possible y value. Now, today we're going to talk about how do we do that with a continuous function. So I'm going to zoom in a little bit here, guys, so we can get a good picture of number 1. Okay, that's what I want us to do. I want us to look at graph number 1. And I want us to talk about, oh gosh, I keep writing on this thing. I'm on my iPad, and you know, my pencil is just not working so great for me here. Okay, so here's number 1 again. So we're supposed to find the domain and range. Now, this does not look like the graphs we had yesterday, right? So yesterday when we had a graph, it just had ordered. Guys, why is this thing fighting with me so much? I don't know what it's doing. It's got a mind of its own. There we go. Maybe if I don't touch it, it'll be okay. We need to find all possible x and y values. So think about our pictures from yesterday. They were actually points. We could count them. We had 1, 2, 3, 4, 5 points or 4 points. We could count them. That was discrete because we could count. Today, if I need to list out every single possible x value on this graph, that's impossible. It is absolutely impossible. I'm going to zoom in so I can explain to you why that is impossible for me to do. I cannot list out all my x values. Yes, I have the x value of 0 on this line, and then right here I have an x value of -1. I see I have -2 and -3, -4, but that's not all of them. What about this x value right here? Well, that's really -3 I don't know, maybe 8 or 7.5. What about this little x value here? Well, that's -3 I don't know, maybe like 7.2. Guys, you have to think about it. Notice in between these 2 points right here is every single value in between -3 and -4. Likewise on this side, I know I do have the x value of 1 on this picture. I also have the x value of 0, but I got to talk about all these x values in between here too. So that's every single value in between 0 and 1. Think about it. There's an infinite number of values in between 0 and 1. I cannot list them all out. I can't say 0.00000000001, 0.000000002, 0.00000, and then I have to keep going until I get to 0.1, and then 0.11111, and then 0.1111. Think about it, guys. You should know this. There's an infinite amount of values in between every single whole number. So there is absolutely no way we could ever list these out individually. That's why we don't say this is discrete. We call this continuous. Now, we can still represent all of those values, but we're going to do it with a different type of notation. We're going to use inequality symbols because those inequality symbols mean all the values in between certain values, okay? So I'm going to show you how we're going to do this. So when you're listing out your domain, remember, that's all your x values. And when you're listing out your range, you're looking for your y. We got to keep remembering that. So here's what we do. When you list your domain, your x values, I really need to look from left to right. Isn't that what where our x is? X goes from left to right here. So I need to know what's my very smallest x value and what's my largest x value. So here's the easiest thing to do. When I have a graph that's a line, I like to list my ordered pairs out. Where does my graph end and where does it begin? Well, over here, I know it starts right here. And I can list out, I can list out these x values right here. It's a dark colored in dot. So I know it's -4, and then the y value there is 3. Now over here, what are these values over here? Well, I've got an x value of 4, and I have a y value of -3. See how that worked? So I can represent every single value in between. So I need to do my x's first. So let's do our domain. Well, I can see that I start at -4, and I go all the way up to +4. And there's a reason I left all that space in between. So my smallest x value possible is -4. My picture does not go past -4 over here. My picture does not go past +4 on this side. Okay, do we agree? Yes. So now what I do is I say, well, how do I represent every single number in between there? I can do that with inequality symbols. And I know I'm using X's, and I write my symbols this way. This means all the numbers, all the X's that are greater than, because the big N's pointing towards X, -4, but that are smaller than +4. That's what that notation means. All the numbers in between -4 and 4. So now we have to come back and say, but do we include -4 and 4? Are -4 and 4 included in our graph? Well, yes, they are, because over here, our endpoints are solid colored in endpoints. They were colored in circles. So I got to put those lines underneath my symbols to show that I need all the numbers in between -4 and 4, and I got to include -4 and 4. Okay, let's look at another one. Let's see how we do this with another one. Here is 2. I'm going to slide over. So again, oh wait, I didn't do my range. Let me come back and do the range first. Yeah, let's do that. I'm not going to do all the domains and all the ranges. I'm going to do domain and I'm going to do range for each one. So let me scoot down just a tad. So let me come back over here. So here is my range. Let's find the range. I already have my endpoints written out. So I always got to start with my smallest. I need to start with my smallest y. You always, smallest x, smallest y. Start with the smallest one. Well, it's -3. My biggest one is +3. I can see that easily. Y's got to go in the middle. Then you always write your symbols this way. If you write your smallest number first and your largest one last over here, if you write them from smallest to largest, you just stick your variable in the middle, and then you decide, do I need lines underneath my symbols? You write your symbols this way every time. They're always going to be pointing to the left, because this says all the y's that are bigger than -3, but smaller in here, +3. Then you decide, last thing, do I put lines underneath my symbols? Why, yes, because I've covered them up, but honestly, these endpoints were colored in. So I need lines to show that I have to include the numbers -3 and 3. So then you just decide, do you need a line under your inequality symbols? Let's try that again with number 2 over here. Okay, oops. My iPad is going crazy, guys. Honestly don't know. It's got a mind of its own here. Okay, so let me get this eraser here, see what happened. So back to domain. So remember, the best thing to do at first is list out your endpoints. When you have a line that ends, let's list out some endpoints here. What is this point right here? Well, I can see that it's an x value of -3, and it's a y value of -5. So let's list out the coordinates of this point over here, right here. Well, I see I've got an x value of 3 and a y value of 3. So now I can come and I can write my domain and my range. So I'm going to get my pink for domain. Okay, so I want my smallest x value. Well, it's right here. It's -3. You always have to go left to right. We leave that space in the middle. I put an X in the middle because that's what I'm representing for domain. It's my X values. You can always write your symbols this direction. Now decide if you need lines under them. So look at your little endpoints. Are any of them colored in? They're open. I can't put lines under my symbols because my endpoints are not solid. They do not include the numbers -3 and 3. So this means my possible x values can be absolutely any number in between -3 and 3, but it cannot include -3 and 3. Let's do our range. So remember, y is going to go in the middle, and I'm always going to put these symbols. You can write that first. Now you just need to come and find what's your smallest y value, what's your biggest y value. Now, do we need lines under those symbols? Well, my endpoints are not solid. They're open. So no, I cannot put any lines underneath my symbols. It's as easy as that, okay? So let's look at this one over here. This one, this is number 3. Right there, number 3. Let's find our domain and range. Okay. So I'm going to have to find some points here, right? I got to figure out how far does my graph go left to right. So let's start by writing these endpoints up here, these guys. What is this value of this point right here? Well, I have an x value of -4, and I'm seeing a y value of +4. So that's how far my graph goes over to the left. But now for this one, I see I have a x value of 3 and a y value of 4. But now, does that take in my whole graph? What about down here? Doesn't my graph, that's as high as my graph goes. I agree. What about as low as my graph goes? Isn't there a point down here? My graph is, because I got to think about how far does it go left and right and up and down. So what is this point down here at the very bottom? We actually call this the vertex. Well, my x value is 0, and I got to go down to -5, okay? So that's all my possible edges of my graph. So sometimes we got to know all our possible edges. So now let's figure out what our domain is. Well, I need my absolute leftmost smallest x value. Well, as far as my graph goes over is this part right here. My graph doesn't go any further than this right here. And it doesn't go any further left and right than this right here. So that's this x value here, -4. My graph doesn't go any farther right than this value here, which is 3. So I know I got to put x in the middle, and I got to put these arrows. Now I need to know, do I put a line underneath my symbols? Are my circles colored in? Do I need to include the values -4 and 3? Well, this circle is colored in, and this one is too. They're both solid, so I got to put lines under both of them. So now let's figure out our range. That's y, that's up and down, that's bottom to top. So we got to go bottom to top. What's our very most bottom value down here? Let me change my color. What's my bottommost value down here for y? Remember, we're looking at our y. Well, that's the -5, right? So it only goes as far down as -5. Now, how high up does my graph go? Well, it goes all the way up to these 2 points right here. It doesn't go any further than that. We can clearly see that's the y value 4. So my graph does not go any higher than 4. What do I put in the middle? Y. I always write my symbols this way. And then I say, well, okay, do I put lines underneath my symbols? So up here, both of these dots are colored in, right? Yep, they were solid. So at 4, yeah, I definitely need a line up here at 4 because that was my value. Down here, my y value is -5. So I look at my picture. Let me erase because I did write over it a little bit there. I look at my picture and I say, down here at my picture, do I have any holes? Are there any gaps in my line there? It's complete solid colored in line. So I do need a line there as well. Okay, so I know that discrete domain and range can be a little bit tricky. So we're going to keep practicing this. I want to look at a couple more with you. I don't want my video to keep going on forever, and you can come into office hours if you want. So I would like to look at number, I think I want to look at number 1 this one here, number 7. So we got to talk about arrows. What if we got some arrows on our graphs? What do we do then? Let's look at number 7. So I'm going to leave the middle row for you guys to do on your own. I think you can do those. And I'm going to do 7, 8, and 9 with you. So I want you to look at number 7 first. So what do I do here? I got to figure out my farthest endpoint. How far does my graph go left and right? Because that's x, right? We're going left and right here for x. Well, I've got arrows on the end of my graph. What does that mean? So does my picture here actually stops right here at this point right here? But when I look closely, I see I actually have an arrow there. So does this line actually stop? Even though my picture stops, does the line actually stop? Because those arrows mean that it keeps going forever and ever, and it never ever stops. So it doesn't stop here on this end, and it doesn't stop at this end either. So when I see arrows on both ends from left to right, that's domain, left and right. That's my x values, left and right. Remember, here's our x values, left and right. I call this all real numbers. Okay, and I'm going to do the number sign, the hashtag symbol for numbers. You can write out numbers if you want to, the word numbers, all real numbers. Because my graph doesn't stop. I can't just stop it at any of these values because I actually have arrows on both ends. So my graph doesn't stop. It takes in every single possible number. So it doesn't matter what number I choose for X, what value, it'll be represented on that line because it keeps going forever and ever, left and right. So now let's look at going up and down. So if I'm talking about the farthest it goes up and down, that's this direction here, right? Up and down. We're talking about going up and down here. How far does my graph go? Well, notice my line is a little tilted here. And again, at my farthest point up here at the top, my farthest point up here, I still have an arrow. So it keeps going up and it keeps going down forever because I still have arrows on both ends. So my range is also all real numbers. And again, you can write out the word numbers if you want. I'm using the hashtag to make it a little bit shorter. So let's look at number 8 then, okay? So we're going to talk about our domain, which is our X, left to right. Well, can I draw? Does my picture does actually stop here. I agree. My picture on this page doesn't go any further. But wait a second. Look very, very closely here. What do we see at each endpoint? Well, I see arrows. Yes, I do see arrows. So that means even though my picture stops here, my actual graph, the line, never ever stops. So I can't block it in with these boundaries, these borders right here. I can't say it stops here because it doesn't. It keeps going left and right. That's what those arrows mean. This U-shape, upside down U-shape, kind of like a rainbow, is getting wider and wider and it keeps growing forever. So our domain is going to be all real numbers. I'll write out numbers this time. All real numbers. Okay, glad we cleared that up. So now I want to look and say, well, all right, then what is my range? How far up and down does my graph go? Well, I can see that my graph doesn't go any further, any higher than this, right? Is my picture any higher than that? Are there any arrows up here at this top bending point here? It's just a solid line. So my picture actually does not go any higher than that. But now look down here. Aren't those arrows going to bust right through that barrier? Even if I put a barrier there, that doesn't matter. It's not going to contain that graph. Those arrows mean it's going to keep going forever and ever down as well. So I can't actually put a barrier there where it's going down. I can say I do not, so remember I want to write my numbers going from smallest, from bottom to top for my range, smallest to largest. Well, I know my largest number is up here. Now I might have to erase because I have really covered over this, but my largest number is up here at this very tippy top point. Well, I notice it's 1, 2, 3. I can't see that number and then 5. So that value right there must be 4. So my largest number for my range is going to be 4. Now remember, Y goes in the middle, and I put these arrows here, the inequality symbols going that way. But I can't really write a number over here because I got those arrows down there, so I don't have a smallest number. So when that happens, you don't even write this side at all. We don't write it at all. And then we have to come back and decide, well, okay, do I need a line underneath my symbol? Don't ever forget to come back and look at the line. Well, up here, my very tip top number, my graph is actually solid. It's colored in completely, okay? There's no holes in my graph there. So yes, I do need a line under it. It includes the value of 4. It actually does touch 4 there. So that's my range. I can have absolutely any Y value at all that is less than, smaller than, or it can't even be equal to 4. Anything smaller than or equal to 4. 4 and everything smaller. Okay, real quick, let's look at number 9. So again, for my domain, I see I have these arrows. I can't box it in. I can't even write that ordered pair, that point there, because that arrow is going to bust through it. It keeps going in both directions. So my domain here is all real numbers. Every single one of them. It's going to keep going left and right forever and ever, this graph is. I can't box it in with these boundaries. Those arrows are going to just bust straight through it. It's not going to stop. Even though my picture stops there, I don't know why. I think it's not erasing. There we go. Even though my picture stops there, those arrows mean that the graph actually does not stop. So let's look at our domain, our range now. Let's look at our X and Y from bottom to top. We want to go from bottom to top for our range. Well, I got to figure out what this value is down here because I see my picture, it does not go any further than this value right here. It stops down there for sure. So I do have a smallest value, and it happens to be this number right here. It's hard to see because I just wrote over it, but that's -5. So remember, I put my symbols like this, and then I put my Y. So now what's my tip top number? What's the highest number that it gets to from bottom to top? Oh, wait, I'm coming to write this top number, but I can't because I have arrows. So my graph never stops going up. So I can't write a number over here on this side. So I'm just going to erase this whole piece over here. I don't need it at all because it keeps going up forever. And I'll look and say, well, down here at the bottom at -5, do I have any holes in my graph there? No, it's a solid colored in line. So I do need a line underneath my symbol. Okay. So we don't always need lines under our symbols, but sometimes we do. We have to figure out, are we including that value? So I know this is kind of a long video, and I know continuous domain and range can be kind of tricky to figure out. We're going to practice this today and tomorrow. If you're confused with doing 4, 5, and 6, jump into my office hours from 10:30 to 12 today. Send me an email or come see me tomorrow, and we'll go over some of these together.